Hi guys, welcome back to lesson 12.7, all about rational expressions with unlike denominators. So today's lesson is a little more dense, and so we're going to get through it, but we're going to go a little bit slow to make sure that we are all on the same page regarding it when we're done. All right. So adding rational expressions with unlike denominators, because remember, we cannot add any fraction together unless we have like denominators. So what do we do when we have unlike denominators? Well, typically when we're just adding or subtracting fractions, we multiply it to get to our least common multiple. And we're going to do the same thing here with rational expressions. So adding rational expressions. The number of years a specific senator's election coincides with the presidential election year is related to the common multiples of 4 and 6. Presidents are every 4 years, senators are every 6 years. The least number of years that will pass until the next election of both a specific senator and the president is the least common multiple of these numbers. The least common multiple is the least number that is common to 2 or more numbers. So example 1 says, what is the least common multiple between these two numbers? Bringing you back over here. So example number 1. Example 1, what is the least common multiple, so the LCM, of 15 m squared b cubed and 18 mb squared. So if you recall from at least pre-algebra, the way that you find the least common multiple differs from your greatest common factor. So for your least common multiple, you need to factor it down to its prime numbers, and then you need to list out every unique term, and then you have to list it to the greatest exponent present. So let's work through this. Let's look at 15. M squared b squared, or b cubed. 15 is broken down to 3 and 5. So now we're going to write it actually here. So 15 m squared b cubed is 3 times 5 times m times m times b times b times b. And now we're going to do the same thing for 18. We have 18 m times b squared. And now we're going to break down 18. We get 3 and 6, 2 and 3. So it breaks down to 2 times 3 times 3 times m times b times b. So far all we've done is factor it. Now when we look to come up with our least common multiple, we list every unique term. So every single digit that's different from another that is involved in either our top and our bottom number, we include. So that means we have a 2, so that has to be in here. Oops, and I write a 3. There has to be a 2. There has to be a 3. We have 3 both in 18 and 15, so 3 gets included no matter what. We have a 5, that's a unique term, so we have to include a 5. We have an m and we have a b. So step 1 was just writing out all of our unique terms to either of our monomials that we're comparing. Next, we're going to go through and we're going to include the greatest numbered exponent for any of our unique terms. So looking at 2, what is our greatest exponential value present? Well, we'll only have a single 2, and it's 2 to the first, so our greatest exponential value is 2 to the first, or just 2. Looking at our 3's, we have a 3 and a 3 in our 18, and a single 3 and 15. So that means our greatest exponential value of 3 comes from our 18, and it's 3 squared, so we're going to include that. We're looking for our greatest exponential value. Next, we have our 5. We only have one 5 present, and it's up here. That makes it 5 to the first, or just 5. Next, we look at our m's. We have a single m here, and we have 2m's and 15m squared b cubed. We take our greatest exponential value, 2 trumps 1, so m squared. Same thing with our b's. We have 2b's and 18m times b squared, but we have 3b's and 15m squared b cubed. So we're going to take the greatest exponential value, which is going to be b cubed. And now we're going to multiply it all together. 2 times 9 times 5 times m squared times b cubed. 9 times 5 is 45. 45 times 2 is 90. So 90 m squared b cubed. And that is our least common multiple by between the monomials 15m squared b cubed and 18mb squared. So it's a little bit of a drawn out process, but it comes back quickly if you remember all of our problems from pre-algebra that we did with this. All right, example 2, finding the least common multiples of polynomials. So 15m squared b cubed and 18m and b squared are all monomials. There's no addition separating any of our terms. But how are we going to find the least common multiple of a polynomial? So for example 2, it's going to require factoring. Shocker there. So example number 2, we're trying to find the least common multiple between x squared plus 8x plus 15 and, oh dear, I'm going to run out of room, x squared plus x minus 6. So let's start by factoring x squared plus 8x plus 15. Well, what are our two multiples of 15 that sum to 8? You should be telling yourself 3 and 5. So if you factor this polynomial, you're going to get x plus 3, x plus 5. And those are our factors. Same thing that we did with the prime factorization tree. We have broken this polynomial down to its simplest factors. We're going to repeat here for x squared plus x minus 6. What are our factors of negative 6 that sum to positive 1? Well, it's going to be 3 and negative 2. So we're going to have x plus 3, x plus, or not x plus, x minus, negative 2. But now we're being told to ask, what is the least common multiple? So we factored these two, but what does that actually mean for least common multiple? Well, remember, least common multiple is every unique term to the greatest exponent represented, right? So in this particular case, what do we have? We have x minus 2. That's our first term. Our second term is we have x plus 3. We're still just going through and listing each of our unique terms. And then we have x plus 5. And now we have to